together. Okay, so that's page 120 of your blue course book. We're applying right angled triangles in solving measurement problems. So we have to measure, we have to do our right angled triangle type thing. Okay. Now, we've read through that, and this is a slightly different one, isn't it? But it's the same assessment but different. Okay. Outside there was a brick wall like that people were sitting on. Okay. The corner of the brick wall here we are calling our D. The A and the B, that is that post that we looked at. So that was the post. Okay? And then this here is length BD, and what I actually said was imagine that this is just twice BD, and that's a right angle. Rather than, I don't want to put a sticker on the concrete, it's too complicated. So at the moment we're just using the corner of the garden, and we're just saying it's a right angle and that's twice that length. Okay, the actual sail, there's a cross thingy, if you like, on that bar that we'll use to say there's the sail. Okay, and so our sail is actually going all the way to there, isn't it? Because that's our BD, so we're actually down here. Does that make sense? Does that make sense? Yes, it makes sense. Okay. So outside you had the post, and you measured, there was the sun, and you measured the shadow of the post. So how long was the shadow of the post? Say again? 250 centimetres? Is that correct? Then you actually measured the shadow of what? You can't calculate the height of the post with just this measurement. We need to know the angle of the sun. So what was the height of the thing you were measuring? 1.5 metres, okay, or 150 centimetres. And what was its shadow? 77 centimetres. Okay, so that's a right angle because you made sure that it was on right angles from the ground because you actually put it alongside the post, yeah? So we knew the thing we were measuring was 150 centimetres high, and we knew the shadow was 77. Now we're going to call the height of the post X. This angle here is the angle that the sun's kind of hitting the ground, if you like. So we're going to say that the opposite over the adjacent of that one equals the opposite over the adjacent, but I better get my units right, the opposite over the adjacent of that one. So X is going to be equal to 150 times 250 over 77. Could I have that, please? The 150 times 250 divided by 77. Okay, so we go 150 centimetres times 250 centimetres divided by 77, and I get 487. Now, does that seem right? Does that pole seem to be over 4.5 metres tall? Maybe?
Yeah, like 3 times.
Yeah? Could be. I think that seems a bit high. Are you sure this was 1.5 metres high? It wasn't a 1 metre ruler? Oh, okay. Alrighty. Now, the other thing that you could do is work out this angle. So how would I work out that angle? If that's opposite and that's adjacent, tangent. So we've got TOA. Because we actually don't have hypotenuse, we don't want to find hypotenuse at this point. So tan theta, so theta equals inverse tan O upon H, which is 150 over 77. So theta equals, and I'm going to go shift set up, and I'm going to make sure that this is actually in degrees, and then I check by going sine of 30 equals 0.5, always do that, and so then I can go shift, undo tan, because I'm finding the angle, 150 divided by 77, and I get 62.8 degrees. What would happen if I did the same for this triangle? If I said theta equals inverse tan, what would I put in there? Opposite, 487 over adjacent, 250. Theta equals, and so I go shift tan bracket 487 divided by 250, close the bracket, and I get 62.8. Now, we didn't need to do that because we knew that they'd be the same. But the reason I've done it is that I've double checked that I've done some good calculations. It's another way of looking at it. And in doing so, I've actually now already got 2/3 of the way to passing, because I've used similar triangles, and I've used Pythagoras. What's another thing that I could calculate that would then I would have passed? The hypotenuse, because that is going to be one of the lengths of the triangle in the sail. So how would I work that out with Pythagoras? So this length here equals this squared plus this squared, and take the square root of the result. But what I'm missing to pass is explaining what it is. So I need to explain what I'm doing. Okay? So I need to say this was 1.5 metres up the pole. I did this because I wanted to get a similar triangle or the angle of the sun, because you can't work out the height of this without more information than just the shadow. Then if you calculated this, you say this is one of the lengths, one of the side lengths of the triangle, which is the sail. Okay, so you've got to say what you're calculating. So this is a bit of a mess. It doesn't have enough writing. So how should we actually write that? Alrighty, let's... Oh, what happened there? I want to maximise them. Okay, right, there we go. Now, so that first thing we had where we had a diagram, and this was 1.5 metres, and this was 77 centimetres. Okay. And I'm going to call that figure A. And then I'm going to have the pole, and this was, the shadow was how much? 250 centimetres. Okay, so I'm going to call that figure B. Alright, now I'm actually going to put theta there, that's opposite, that's adjacent, that's hypotenuse, that's opposite, that's adjacent, that's hypotenuse. Okay, so what might you write? Figure A is, what does it represent? Is of us measuring a known height from the base of the pole. Guys listening, so what else might I say there? Figure A is the diagram of us measuring a known height from the base of the pole. Why did we do this? We did this to find the angle of the sun. Okay? Why did we need the angle of the sun? We needed this to be able to use the shadow length of the pole to what? To calculate, calculate what? The height of the pole. So setting out wise, I've got figure A, I've got figure B. So the next thing I would say is figure B shows the height of the pole and the length of the shadow of the pole. These are similar triangles because they're both using the angle of the sun. Okay, so you can see up here I didn't label my figures and I had sort of calculations all over the place. Here, when I calculate something, I'm actually going to say what I'm calculating. And I'm going to label my figures so that I can actually talk about the right one. Does that make sense? No. Yes, maybe.